Well, hello guys, welcome back to John's Workshop, and in this video we're going to go back onto the Cormak mill head refurb, and we're going to try and correct the mistake that I made in part 4A, where I made a bit of a cock up of trying to recut the gear teeth on this pinion, on the Quill Pinion shaft. So I had some really good comments on that video, changed my thinking a little bit about what we were potentially going to go and do. So I'm just going to run through what's going to be in this video. So we're going to make a new pinion shaft. Some of the comments I had back was to make a sleeve and basically turn down the ropey teeth on here and put a shrink fitter sleeve on, cross pin it, and make use of the rest of the shaft, which is in good order. I've had comments about welding as well, and you know, if I was a half decent welder with decent welding kit and I was confident I could control the distortion in this, because if this distorts at all, then there will be, these two bearing diameters are already finished, so any distortion at all basically renders this useless, because I can't do anything to correct that on a shaft of this size. So welding's out, and my welding's just not up to it. There would be pits and holes and porosity and goodness knows what else in it, so that's not going to happen for me. I've got the material to make a complete new shaft, so that's what we're going to go and do. And we're not going down the sleeve idea because I don't think you can see the board here, but the bottom of the gear teeth is literally 0.2 of a mil diameter bigger than the sort of base material, if you like, of this diameter. Now I could make this diameter smaller, but the face here up to the end bearing diameter is a location face that basically dictates where the shaft sits in the head this way. There is only less than 1.5 millimeters aside of material on that face at the moment, so if I reduce this diameter by any more, which doesn't matter, this diameter does nothing other than create that bearing location face here, there will be not enough material to create that location face, and what I would end up doing is just screwing up the inside of the head or screwing up the end of the shaft, and then I'd end up with lateral play. I just don't think that's a good idea. And obviously a 0.2 of a mil wall thickness, whilst I could make that and shrink it on, when I start to cut the gear teeth, my nervousness is that it will relieve, the stresses in the material will relieve, and this thing won't then be gripped to the shaft. It will then lose its shape, and that will affect my accuracy going up and down on the quill, and it will probably lead to stress cracks at the bottom of the teeth, and I think it will just fall apart. So that's what I'm thinking. I've got the material to make an entire new shaft, so that's what we're going to go and do. So I'm not going to show the gear cutting setup when we get to that bit. If you want to see how I set the machine up to cut the gear teeth, just go and watch episode 4A, because it's going to be a repeat of that setup, so I won't show any of that. I'll just get straight onto the cutting, and we'll get our material loaded up in the lathe and make a start. So we've given our lathe a good clean down, got rid of all the swarf in the swarf pan. We've got our piece of stock loaded up, and I've decided, after doing my planning, that we're going to do this all in one hit. A couple of reasons for that. One, the bar's long enough to get a chucking piece on the end of it, so if I hold the original shaft up there, I've got enough room to turn the whole thing and maybe part it off, or I think I'll probably more likely take it out and put it through the saw when we're done. And also gives me the opportunity to use my fixed steady, which I've never used on this machine. So what we're going to do is do this all in one hit, all in one setup, and we're going to be positioning the fixed steady in a couple of places along the length of this as we go. Well, certainly that's the plan. So the first job is we're going to spin this up, obviously quite slowly, because we've got, a good long length of this sticking out the chuck. So we're just going to go carefully. We're going to put a decent sized centre in this end. We'll get a revolving centre in, and then we'll turn our first diameter section for our fixed steady to rest on so that we can then start attacking the turning from this end. So we've got our best revolving centering, and not sure how this is going to go. I've marked out a section roughly where I'm going to put my fixed steady, I think. So I'm just going to take a light pass down there to clean the OD of the bar up, and we'll see whether we get any vibration or not. Yes, we've got some vibration and a pretty awful surface finish on that. We'll just have a play with that, see if we can get that better before we put our steady in place. That's not very nice at all. I'll bring you back in a minute. Okay, we've got a slightly better finish, and I've gone all the way down the bar. It's a little bit ropey in places, there's a bit of vibration, but not too bad. And this is the first time I'll have tested this lathe over this kind of length. So we're 39.4 at that end, and at this end 39.44. so I've got 0.04 taper, which is about a thou and just over a thou and a half over, yeah, whatever that length is, 300 and something millimeters, so that's not too bad. 360 odd millimeters I think that is. So I might tweak that, or I might, for what I'm doing, that's not going to affect, because each of these are quite short diameters all the way along, so the taper that I'll end up getting across this isn't too bad. But I might as well take the opportunity while I've got something this big in the machine to set the tailstock up. So I'll do that off camera while I've got the opportunity, and then I'll bring you back when we're putting the fixed centre in place to give this some support while we turn this front end. Okay, so we're just getting our fixed steady set up. So I think I've got it roughly in the right position. So we're just going to nip that up where it is. And we can set that up. Just bring them into touch. Okay, got a different tool in, and we're just going to start now. I'm going to face the very end of the bar, get my datum, and then we're going to start turning in for the 3 diameters that I can get at this end of the shaft. Now we've got the fixed steady in place. Okay, we've moved our fixed steady this way, locating on the diameter that we've just turned, and we've reset our carriage stop, and everything's reset now up for the next diameter that we're going to turn, and then we'll do all of that again for the final diameter. So same procedure, so I'm not showing it again, and I'll crack on now and turn this second diameter in exactly the same way as I've done the first one. I'll show you a little bit of that, and I'll show you a little bit of the second one as we get down to this end, and then we've got a bit of a bigger changeover then as we start to come the other side of the steady to machine the rest of the shaft. It's the second diameter done. I'm 0.01 off the mark, so happy with that. So I'm now going to get set up for the final diameter at this end. Okay, we've got our final bearing diameter finished, and we've got a parting off tool loaded in because on the original part you'll see there's an undercut in that corner. So we're just going to put that in, and we've got our length set correctly from the end of the shaft to that shoulder. So we're just going to try this. I've got a feeling it's going to chatter, but we'll give it a go anyway. Yep, chattery. Slow it down a bit. I'm going to put one in, but it's not the best. I'm just going to move the camera. Okay, we're just using the, I don't know whether it was a Stefan or Joe Piezinski trick, and I'm just turning the chuck by hand. At least that way the thing's not going to come flying out and join me in the workshop. Done. So, I'd not mentioned this. It's been great using that. It's the first time I've used a fixed steady for, oh, I don't know, 25 years probably a bit longer. So this was a kind, very very kind subscriber donation to the channel some time ago. I've not yet had a chance to use it, so it's been good to use that. So we've now taken that off, we've given it a clean down, we've cleaned our lathe down, we've put some fresh oil on the slideways, and we're now ready for round 2, which is the second half of the shaft. And I'm not going to be able to get the fixed steady back on, so probably going to be fighting vibration a little bit, certainly on this next diameter along, but we'll see how we get on. We're going for 35.98 and we're 35.985, but that has got a tiny bit of heat in it, so happy with that. That's our central section done. Now we've got to dig in and machine this back section, which I'm going to have to do in 2 halves, Now this back section is a bearing diameter at one end and at the other, but in the middle it's in clearance, so I'll use the middle bit to make the transition between the left hand tool and the right hand tool. It really won't matter. So that's the next job. Okay, we've cut our first side, we've finished this diameter up to the chuck. We're now cutting backwards towards the tailstock. I'm using the same tool because I want to try and keep the same insert and everything, same finish, and I'm running the lathe in reverse because I've got the tool sitting upside down and it's just on centre. So we're just gonna, I'll show you a little bit of that and then I'll bring you back when we're getting close to finish. Okay, we've got our back end diameter finished, so now I'm just going to pan to the right. Got our parting off tool set with the back edge of the tool on this edge where we've put the undercut, and what we're going to do now is I'm going to move pan down to where my carriage stop button is, and basically we've got a set of slips. This is going to be a bit fiddly, but I'm going to hold the slips up against the carriage stop button and I'm going to bring my carriage stop in until I've got the right feel on that slip pile. Yeah, happy with that. And that's now set my critical length for finishing off the back side of this shoulder. So we're just going to come in with the parting tool now and work to that carriage stop position, and that should be me at the correct critical length between those two shoulders. Okay, so we'll just do a final check on our 3 bearing diameters. So we're on 0. We've pretty much got no movement on the clock. I'm going to have to move the tripod, bear with me. So we're now on our main middle bearing diameter. No movement. And then I'm going to need to move the tripod again. We come out to our end bearing journal, or bearing diameter. Okay, we're on 0. And this is a 5/10 per division clock. We've got about 1 division, so all 3 bearing journals are running within 5/10 of each other concentricity, which for a home shop I think is pretty good. So next job, I'm going to get this out, get it chopped off in the saw. I'm not going to try and part this off, I'm not that brave, and then we'll tidy it up and I'll bring you back when we get to the mill to put the teeth in. Okay, so in the interest of time, the amount of time I've had in the workshop this week and keeping the videos to a reasonable length, that's going to be it for this week. So that's got the turning of the shaft complete. So in next week's video we'll be moving on to the gear cutting and the final bits and pieces that we need to do to finish this off. So I hope you've enjoyed that, something a bit different. Thank you to the subscribers and the new subscribers as always, and we'll catch you all very soon on another video when we'll be making something else.